Hello and Assalamu alaikum. My name is Luqman Hakim bin Zulkifli, an electronic system engineering student studying in Malaysia, Japan, International Institute of Technology, University Technology Malaysia. My final year project title is Autonomous Robot Car Simulation and Control Using Mobile Apps. An ideal version of what seems to be the future of modern transportation, autonomous vehicles are a topic of intensive research by universities, researchers, and car companies as far back as 1980s. Nowadays, autonomous vehicles have become pertinent as companies like Tesla and Renault and many more have already released model vehicles that have an autopilot system where the vehicle enters almost autonomous driving mode. As such companies continue to develop better approaches to improve autonomous driving technology, the world will slowly but surely transition to this new modern lifestyle. Speaking of modern lifestyle, smartphones, on the other hand, are one of the most advanced pieces of technology to which almost everybody have access to. Today, many applications for smartphones have been developed, one of them being remote control for devices through integrated communication protocols such as Bluetooth and Wi Fi, and many more. What makes autonomous vehicles apparent today is the ability to sense its environment while driving safely with little to no human control. By having a variety of built-in sensors such as radars, lidars, and GPS to help perceive the surroundings, these smart cars are programmed to intelligently navigate to their destination, making decisions to stay or switch lanes and able to detect blind spots. However, the technology is yet to be perfect and often experience setbacks. Such setbacks can be fatal, not only for the driver but for others on the road as well. While autonomous cars are being researched and developed, there are not many mobile app remote controlled autonomous vehicles presently. That being said, this project proposes mobile apps as a mean to control and navigate autonomous robot cars in a simulation. The objectives of this project are as follows: 1. To design a 3D robot car simulation. 2. To optimize the accuracy of its mapping algorithm. And 3. To control and navigate the 3D robot car simulation through a mobile app. The scope of this research will be on robotic simulation, autonomous motion navigating, and connection from PC server to mobile phone application. The study will develop a robot car simulation using ROS as middleware and Gazebo simulator. Then, study the mapping algorithm to train the robot car to map the entire simulation environment and determine the best parameters to get the most accurate mapping results. The mapping results is then used to experiment with the robot car's obstacle avoidance capabilities during autonomous navigating. Finally, to connect the simulation to a downloadable mobile app called ROS Mobile via PC server and control the robot car simulation through the mobile app. In this project, the design, mapping, and navigation of robot car simulation were created with close reference to the Robotics e-manual website, where it teaches you step-by-step tutorial on packages to download and how to simulate and control a 3D turtlebot robot inside prepared simulation environments. The robot car design is mostly influenced by the dimensions of the Turtlebot 3 waffle pie model, such as wheel length and diameter and the position of sensor relative to ground. Table shown compares the dimensions of the Turtlebot 3 waffle pie and the designed robot car. As you can see, the wheel dimensions and sensor dimensions are similar. As for the simulation environment, the provided simulation environments such as the Turtlebot 3 World and the Turtlebot 3 House World are used as early driving routes for the robot car. Obstacles such as pillars, walls, and furniture sets are present as variants during robot car driving simulation. Next, new simulation environments were created using Gazebo Building Editor feature. Two environments were created which are KSJ Room World and KSJ Corridor World. These environments are designed replicas based from College Siswajaya University Technology Malaysia Hostel Room and Corridor respectively. Obstacles such as lockers, beds, trash cans, and benches are included similar to the real life ones. Measurements of each exterior was measured manually using a measuring tape. To get the robot car to drive autonomously, the robot car must first need to familiarize itself with its environment. This can be done by controlling the robot car to map the entire environment to create a 2D map of the environment layout using simultaneous localization and mapping algorithm, or SLAM for short. It generates a map of the environment the robot car's sensors picked up and simultaneously locates its position. To demonstrate the autonomous driving simulation, here I have two programs running. One is the robot car in the 3D simulator, and the right one is the robot car in the generated map for not for navigation purposes. So if I set a destination to go here, as you can see, the robot is generating a route to reach the destination. And here, in the simulator, the robot is moving in corresponds to my set point to reach the destination. The mapping process and autonomous navigating tests were executed on all four simulation environments to experiment with the mapping accuracy. It is found that the 2D map generated from mappings of the Turbot 3 world, Turbot 3 house world, and KSJ room world are quite accurate and able to drive autonomously with little to no error. However, mapping for KSJ corridor world created inaccurate 2D maps dimensions. For instance, the length between this point and this point is 38 meters, but the map generator is only 5 to 6 meters. This problem is known as the corridor problem, where the mapping algorithm thinks that the robot car is not moving when its sensor scans data are always the same in long corridors. Two different approaches were tested to solve the corridor problem. First is adjusting the parameters of the mapping algorithm. Table shown is the trial and error of different value parameters of the mapping algorithm with different value combinations to get the actual corridor length as close as possible to the real one. It is shown that if the parameter radar beams to be skipped increases, it will allow less computation for detailed work for the mapping algorithm and thus will prioritize on the radar distance aspect of mapping. Even though the change did increase precision of mapping, it is still not accurate and the results are not consistent with multiple trials. The second approach is adding obstacles along the corridor so that the mapping algorithm can sense some change when mapping the corridor and assume that the robot car is certainly moving. This approach works well, and the resulting 2D map generated is accurate, having the same length as the environment. Hence, the second approach was used as the solution to the corridor problem due to better mapping accuracy. The environment simulation of KSJ corridor world was changed by adding trash cans along the corridor. Finally, is testing out the simulation in a mobile app. On the left is the robot car in the 3D simulator, and on the right is the projection of my phone. For this project, I'm using ROS mobile app. ROS mobile app is a downloadable app that is compatible with ROS related robotic projects and comes with an intuitive user interface for controlling and monitoring robotic systems. First is connecting the phone's IP address to the simulation computer's IP address. Once connected, users can add widgets such as joystick to control the robot, camera to view the environment from the robot's view angle, and many more. The robot car simulation can be controlled and mapped from the mobile app, and the navigation driving can be visualized from it also. As you can see, the robot is moving when I use the joystick. To summarize, this project aims to control an autonomous robot car simulation via a mobile app. The robot car simulation was designed and tested in different simulation environments. The robot car's mapping accuracy was tested and improved. And finally, using a mobile app to connect and control the robot car simulation. Thank you.